And if I go to the next slide, I am now ready to define what Kc is. But instead of giving a complicated formula, let me give you a simple example. Hi, Lita. So this is an equilibrium reaction. How do I know? By double arrow. What did we say about equilibrium reaction? We say equilibrium reaction is a reaction at which all reactants and products have come to a fixed concentration. A reaction is at equilibrium where all reactants and products have reached a fixed concentration. And you already know bracket means concentration. So I have reactants. On the bottom, products on the top. So write products, concentration of product, is an O2 on the top. If there is any coefficient, coefficient becomes power term of concentration. Divided by reactants, concentration of reactant. The only reactant is N2O4, concentration of N2O4. What is the coefficient here? 1. Anything to the power of 1 is the same, so we don't write this. So that's how you can calculate the value of equilibrium constant. So equilibrium constant is a fixed number, which is resulting of ratio of fixed concentrations of product and reactant once an equilibrium reaction has reached equilibrium. Why do I say that? Because when you have an equilibrium reaction at the beginning, you have some reactant and you have some product. As reaction forwards, product is made more, less reactant. At certain point, concentrations are not changing. That is the point of equilibrium of concentration. So at a given temperature, as you saw, temperature affects the direction of an equilibrium. So when we define equilibrium constant, you must give temperature. Equilibrium constant at, let's say, temperature of 700 is equal to 4.5 times 10 to the power of, let's say, -3. You may say, how do I do that? How do I calculate K? We run the experiment. We measure concentrations of products and reactants. Then all you have to do, use this formula. And in this case, after, if we give you the concentrations at the given temperature for this equilibrium constant, enter the concentrations into your calculator, then you have the equilibrium constant. What is this telling you? The fact, is this smaller than 1? Is this 0.00463, very small, smaller than 1? It's telling you this equilibrium is making less product and remains mostly as reactant. That means the bottom of this ratio is much larger than the top of this ratio. And that's why the equilibrium constant is less than 1. So this equilibrium doesn't go very far towards right. It remains mostly as reactant. So I'm going to give you an example. This is the chemical equilibrium, CO, carbon monoxide, reacting with chlorine, forming COCl2. We run the reaction, we measure all the concentrations, and we give you when reaction is reaching at equilibrium. That means when concentrations are not changing anymore. We give you the temperature. These studies were done at 74 degrees of Celsius. Concentration, when concentration of CO is fixed, it's 0.012. And concentration of unreacted Cl2 is measured. Concentration of amount of product which is fixed is measured. Can you calculate the equilibrium constant? The equilibrium constant is Kc. C stands for concentration. K is constant. C stands for concentrations. So we say equilibrium constant, which is based on measurement of concentration, Kc, is equal, as we said, concentration of products on top. There is no coefficient, so I don't write the power. Divided by concentration of reactants. Bracket for concentration, reactant CO, bracket for concentration, Cl2. Both of these have got a coefficient of 1. That means power term is 1, so we don't write it. So you enter the given numbers from the problem. Concentration of CO was given 0.12. Concentration of Cl2 was 0.054. Plug it in, you get 220. It's a very large number. That means the top of this concentration of product is much larger than unreacted starting material. That means this reaction goes far to the right. Small amount of reactant remains in the mixture. Are you with me, guys? Any questions?
Yes. Will we always be given the concentration numbers, or do we have to figure that out on our own?
No. As I said, chemistry is experimental science. We run reaction, we make observation, we do measurement, then we come up with the result. It's like you looking at me and telling me how heavy I am or how tall I am. You have to use a measurement tool. So these are done in the lab. You will be given the information.